All right. I am Lawson Owen, and I am with the MBA program.
And I'm Hannah Johnson. I'm with the Masters in Applied Data Analytics program.
And this is the Prysmian Group project proposal for summer session 1 of 2018 for CIS 5860. So just a little background. Prysmian Group is a multinational company headquartered in Milan, Italy. The company produces products for electrical power transmission and telecommunication cables and systems. Based off of revenue, it is the largest manufacturer of cables in the world. They currently have 21,000 employees within 50 countries and 82 plants worldwide, along with boasting over 140 years of experience. In 2017 alone, they amassed over 7.9 billion euros in revenue.
So the business problem we're analyzing is the first step undergoing the process of cable production for Prysmian. It involves obtaining hollow glass rods from a supplier and purifying them through a process called plasma chemical vapor deposition, or PCVD. This process includes several purification steps, including the infusion of raw materials in order to create a pure core of the glass rod. During PCVD, a variety of factors, both known and unknown, can lead to the formation of bubbles within the glass rod itself. And while some bubbles are allowed, too many will render the rod unusable for further production. Each rod scrapped costs roughly $2,000 of production cost, and the current rate of scrapped rods with this issue is costing the company approximately $2,500,000 each year.
So the importance of this problem is that the problem directly impacts the company's bottom line. So as mentioned in the previous slide, each rod has a cost of $2,000 associated with it, whether it be materials, time, or labor, with a total expense of over $250,000 per year. This slows down the production process for future rods as they are delayed and then have to be remanufactured again because they are scrapped. This in return affects orders and the reputation of the reliability of the company as it is perceived by potential customers, and this could eventually lead to bottlenecks further down the line.
The dataset and all other pertaining information were inherited from the group prior. We have collected their analysis, hypotheses, and all of the work they've completed up to this point. The data we are analyzing comes from sensors within the production machine itself, of which there are 135 variables measured at 5-second intervals for the entirety of the 11-hour process. This information was combined by the prior team with quality control data as well as coolant water temperatures from the factory floor. Using SAS, R, and Excel, we hope to manage all of these data points and identify any critical factors that result in bubble formation. Overall, any sort of information that can pinpoint causes to bubble formation will help increase the bottom line of the factory as well as limit the issue of wasted resources and time. The goal is to analyze all available data and ultimately develop a model that will assist waste reduction in the PCVD process.
So scope and deliverables. We have basically managed our entire project into 4 phases based off the tasks and the deadlines associated with each task. So for phase 1, we have scheduled a tour of the facility, which is located in Claremont, North Carolina, for the week of June 11th to the 15th. And then in the meantime, we'll continue to review work that was done by the previous group and then develop a game plan for analysis. This leaves us with a deadline of the middle of June. Phase 2 is we are going to create and refine models that had already been created for predictive analysis and then perform said analysis. And we expect this to take until the middle of July. Phase 3 is to determine important variables and critical factors and then continue that analysis based off of those critical factors. And then from that analysis, we hope to interpret the results and then begin the reporting process, which will hopefully end around early August. And then finally, phase 4, we hope to make a presentation of the findings and recommendations to the stakeholders as well as the graduate program. And this is set for early August as well.
Ultimately, the outcome of this project has potentially large implications for the Prysmian group. There will be more information about the cause of bubbles in the production process as a result of our analysis, and predictive power could help determine which batches will be scrapped prior to production. Detailed analysis can explain what is causing the bubbles and allow for adjustments to be made in the future. And less materials will hopefully be scrapped yearly, less time wasted, and the cost associated will also be limited.
And that is all for the proposal for the Prysmian Group project. Thank you for listening.